seem a little bit redundant that we keep going over what the sides are, but when it comes time for the test, I won't be providing you a picture or a chart that says this side is x, this side is x, this side is x squared root of 2. Like, you have to know those things, okay? So I feel like if we go over it enough times, it's not going to be something you have to try and memorize outside of class. We've done it enough times, you already know, okay? So the first thing they ask is, what is the chart, or what do you write for the sides on a 45, 45, 90 triangle? So what do we call the sides that are across from 45? X. Okay? And across from the 90 is, okay? Realize that they could call those sides any letter, right? X is just a placeholder. They could call the sides like n, and n square root of 2. It doesn't matter what they call it, right? So don't ever be thrown off just because they use a different letter. All right, so we know that this is what our 45, 45, 90 looks like because those two sides have to be congruent, right? Okay? So these two angles are going to be congruent, meaning those two sides have to be congruent. So they ask, what shape or key terms are generally used to let you know you have a 45, 45, 90? So let's say they didn't write 45 degrees on those two. How could you still know it was going to be a 45, 45, 90? What could they give you? Huh? The 90-degree angle, right? That would tell us that this angle is 90 degrees, but what would they also have to tell us about the other ones? Right. So if we have a triangle with two congruent sides, what kind of a triangle is that? Isosceles. So they could just tell you that you have an isosceles right triangle, and you would automatically know that it's a 45, 45, 90. Okay? Or they could just tell you that you have a right triangle with two congruent legs, right? They could write it out that way. So right triangle with two congruent legs. Okay? Right? Does anybody remember when we were doing the 45, 45, 90 notes, what figure was drawn at the top for us to prove what the sides would be? A square, right? They just had a square with the diagonal drawn down the middle. So they could also give you that, right? You could have a square, and you would know that it would make two 45, 45, 90s. So they may not come out and write that you have 45-degree angles, but if they say or give a picture of any of these things, you automatically know it's a 45, 45, 90. Okay? Okay? So then they give us one to solve. It says opposite the 90-degree angle is equal to 6. Okay, so they didn't draw a picture, but the side opposite of 90, what do we label it? X squared root of 2. Good. So x squared root of 2 must be equal to, and then we can just solve, right? All right, so what are we going to do to get x by itself? Okay. But we can't leave that square root in the bottom, so then what do we need to do? All right, so in the top we've got, very good. Perfect. Simplifies to 3 square root of 2. Very good. Okay, so the value of n, or the value of x, whatever letter they choose to use, is 3 square root of 2. Okay. All right, same idea for 30, 60, 90. What do we label that side across from 30? X, or any letter they choose to use, right? What about across from 60? Yes, and 2x. Very good. Okay, then they ask what shape, what could they give us to let us know that we're going to have a 30, 60, 90? Well, we know that it's going to look something like this, right? This leg has got to be shorter than the other leg. It's got to be across from 90. But if they don't specifically tell us how many degrees something is, this one's a little harder to tell, right? So, just because they say something about the legs, that wouldn't tell us necessarily that it's 30, 60, 90. What kind of figure did they have drawn when we proved a 30, 60, 90 at the top of the page? What? Not a rectangle. An equilateral triangle. Very good. Okay. So, they could draw an equilateral, equilateral triangle, and I would automatically know if I draw a line down the middle that I've got 30, 60, 90. Okay? So remember, it looks something like this. We knew that all the sides were congruent, right? And if we said that this little piece was x, then a whole side was 2x, right? And then we proved that that other leg was x squared root of 3 using Pythagorean theorem. Okay. All right, so then it says, if the side opposite of the 60 in this kind of a triangle is 9, what is the value of n? Okay, so what do we label the side across from 60? X squared root of 3 or n squared root of 3, good. Should be equal to, okay? So what will we do to solve? Divide. Okay, then what? Okay, so we end up with, which simplifies, right? Very good. So there's our value for n. Okay. So on the assignment that you're about to get that goes with these, they aren't going to draw the picture for you. Okay? So you have to figure out what goes where. They give you hints to maybe draw the picture yourself or make a table like we did here.